Alright, so this is the pre-test. Next week will be the test. It'll be pretty much the same part, pretty similar. But we're going to go through this. It kind of accumulates all of the different stuff we've learned and adds a couple small new things. Tool list is up here. Depending on which version of the software you're using, you may have a couple issues. I'll try and go through it the best way I can think of for the older software. The newer software, it's a lot easier to do some of this stuff, but we'll go over it the way we did it in class. So we'll go ahead and get started. So first thing we need to do is create these tools and get our stock geometry set up. So first we'll save our program. Alright, so we gotta get our tool set up. I'll make tool number 1 my 90-degree chamfer mill. We haven't done this yet in class, so I'll kind of explain it through how we use the chamfer mill when we get to that part. We'll save that for the very last. But for now, we'll go ahead and call it an end mill, and we're going to call the diameter 0.1, and I'll explain that a little bit more later on. We can set our speeds and feeds here. We're going to make tool 10 this number 7 drill. And then make tool 60 our end mill. That's going to be a 3/8. And we'll go ahead and create tool 61 also. We're going to make that a 1/4 inch end mill, just in case we need it. We ran across some issues in class with the older software. They didn't make some of the stuff work right, so we ended up having to use a 1/4 inch end mill. So we'll see if we get to that. Just let me know if you have any problems, depending on which software you're using. They should be upgrading the ones in class sometime this week or next week, so that'll fix a lot of those problems. Alright, so we got all of our tools set up. We'll go ahead and get our stock geometry set up. So we go to our part setup, stock geometry, and manual stock sizing. Alright, so now go ahead and start programming. So it's however you want to do it to program all this. Depending on the material, you'd probably actually have to do a lot more to this part. But if we assume it's aluminum, just the list of tools we've chosen should be okay. But probably the easiest way to do this is we'll go ahead and drill these holes first. So we'll go ahead and get that going. Alright, so we're going to do a hole drill operation, and we'll start your Z positive. Now make sure your Z bottom's through the part. Alright, remember we're going to do a bolt circle. So we can see this is obviously a bolt circle, and it calls out 1.72 the diameter. So just half that for the radius. And it's centered at 4 inches and 1.5 inches. Now for our start angle, we can just leave it at 0. Because remember, with the the bolt circle, the first hole is at the 3 o'clock position. So if we look here, we can see we're at the 3 o'clock position already, so we don't need to angle anything, and we can just leave it as is. And then we can see there are 8 holes. None of them are skipped, so we should be good how it is. So we can go ahead and draw this real quick and see what we get. And that looks right. So we should be good for now. Now we'll move on, and we're going to start milling this. So we're going to insert milling, and depends on what we want to do. We could do the outside, we could do any of these pockets. We'll go ahead and do the outside. We'll just do a mill frame to start with. And we have our X corner is 0.25 and our Y corner is 0.25. And they give us the lengths of they don't call out the X lengths, but we can just assume that it's equidistant. So that 1/4 inch will be on both sides. So we'll put it at 6.5. And then it calls out the Y as 2.5. The depth of that is -0.15. And they give us a 75 thou corner radius. The start side, we should be fine, leaving it as just the bottom for now. Go ahead and do tool 60. Okay, remember to do milling type outside for this type of path. Remember, if we're on the inside of something like this, we want to do inside, or a pocket boundary. If we're on the outside, we do outside. We can go ahead and do a pec depth if we want to. Don't really need it, but we can put it in there. Plunge feed, we can do 50 thou. Alright, so we'll go ahead and do a finishing pass also. So we just click on this finishing tab. We can program tool 60 as our finisher. And that finishing amount is going to be predetermined by our program parameters. So if we go into the program parameters here, we go to milling 1, you can see finish XY, finish Z. So we could change these if we wanted to. They should be fine for now. You never want to leave, for the most part, you don't want to leave more than 10 thou either way. And you usually don't want to leave less than 2 thou. It really depends on your material and your type of tool and all that. And once it's set here, it's set for the whole program. But we can also add change parameters in the program. So say if for just this one milling block we wanted to have a small finish, and then for the rest of it we want to go back to the normal finish, we got to change parameters before, tweak it, then add another change parameters to turn it back to normal. But we won't worry about that for this part. Alright, so it looks like we got pretty much everything taken care of here. Go ahead and draw it, see what we get. So we look good here. If we zoom in here, we can see we're plunging. We may be plunging clear, or we may be plunging on the material. So we go to our program parameters, and we talked about this before with the milling 1, this blend offset. We can actually make this bigger. So if we make this like 0.35, now we draw it again. Should have a nice big blend. You can see how it's bigger now. So we should be plunging outside the material. You almost never want to plunge onto your material unless you have to. Alright, so that's it for the outside. So we'll go ahead and we'll do this circle and this ellipse, and then we'll go back to this little frame. With the new software, you can do this as just a frame. With the older software, you actually have to use lines and arcs because the corners are different sizes. With the new software, you can change the size for each corner. But with this software, with the older software, you have to program it as lines and arcs. So we'll go ahead and do the circle and the ellipse first. Alright, so remember milling type, we're going to do a pocket boundary. If you don't do a pocket boundary, it'll just mill along this edge here, and you'll be left with a slug in the middle. If you're doing plastic or something soft like that, it wouldn't really matter, but since we're doing aluminum, when it gets down to the bottom, that little slug could catch the end mill and break it. So always keep in mind of what's going on with your material. This pocket overlap we can leave. We can make pocket type outward. And we'll peck this probably about 0.15. Do a real slow plunge feed. And since we're pecking this, we want to go ahead and throw a finishing pass in there. Anytime you have a peck, you want to go ahead and throw a finish pass in there also. I can throw the finishing plunge feed up to 50 because we know we'll be clear through the part, so it won't be hitting any material. So once you break through, you can go as fast as you want. Alright, go ahead and draw it, see what we get. So we got a nice hole there. Go ahead and go on to the next block. This time we're going to do the ellipse. Same exact center point. Remember, they're asking for the radius here, not the diameter. Since we've already made this hole, we could actually probably make this plunge feed really, really high. Because when you do a pocket boundary, it's always going to plunge directly in the center of your geometry, unless you have really, really obscure geometry, like some crazy weird shape. If you have a circle or an ellipse or some sort of box frame, they'll always plunge that end mill dead center. So we know this is already removed from the middle, so if we wanted to, we could bring this up to 100. And we know we'd be completely clear of any material. Again, we'll throw a finishing pass in there. Go ahead and draw it, see what we get. Alright, so it looks good. Now all we got left is this, the frame here and these counterbores. So we're going to do each of these two different ways, just depending on the software you have. We had some glitches with the software at school, so in case you have those same glitches, we'll go ahead and program everything both ways. So starting out this frame here, we're going to do lines and arcs. So just pick a start point that you know is easy to get to. I'm just going to pick right in the middle here. So it's going to be the center of the part, basically, 1.5 inches. And I'll do X of 2.25. So just right there. And then we'll use the blend arcs instead of doing actual arcs. We'll just take these lines to the imaginary corners here where these lines would intersect, and then we'll just throw blend arcs in. That way we don't have to calculate all the individual points, because that's kind of a waste of time with something like this. So you just go straight to the corner, throw a blend arc in, and you're done. So we'll go ahead and walk through that real quick. So we're starting out at 2.25 and a Y of 1.5. And our depth's going to be 0.4. And we're going to do a pocket boundary. Alright, so we're going to do the pocket boundary, and then go ahead and set our peck depth. And we'll throw in a finish pass as well. Alright, so go ahead and go to the next segment, and we're just going to move straight up to this corner, and then just continue that way. And the thing with pocket boundaries is we have to end at the exact same point we started. So make sure you end that last point right where you started. Alright, so we just ended right here. So we can go ahead and throw our blend arc in, and then go over to the corner. It's 0.2543. Do a line. Now we're going to end at point. What is it? 0.5. And we're going to keep the same Y. Do another blend arc. Then we're going to go down to the bottom left hand corner. Throw another blend arc at 0.51. And we're going to go to the bottom right corner. Throw another blend arc in. And this one's a little different. It's 2.2476. And now finally we're going to end with a line. And that line's going to end right where we started. You always have to do that anytime you do a pocket boundary. It has to be a closed boundary. So now we'll go ahead and draw us and see what we get. Alright, that looks good. Now I'll show you the other way to do this. So we'll go ahead and go to a new block, get a milling, and we'll do frame. So I have the 9.01 version. The school is currently on the 7.01 version, so it doesn't have this feature. But I'll show it to you anyway. If you're programming at home on the software download I gave you, you should be able to do this. It's a lot easier to do it this way. So again, we just pick our corners. So 0.5 and 0.75. So it's just like any other frame we've done before, except we can pick the size of each corner. Do a pocket boundary. Finish in there. Now if we go to this corner section, we can see all the different corners. And they label them for you so you can pick the right ones. So we know corner 1 is going to be 0.51. Corner 4 is going to be 0.51. Corner number 3 is 0.2543. And corner number 2 is 0.2476. Now if we draw it, it should match up exactly and we shouldn't be able to see any differences. So if we zoom in, they look exactly the same. You can't tell any difference. So go ahead and zoom back out. I'll just leave this here for now. You don't have to do both. I was just showing you how to do both. Now for this next part, we're going to do these counter bores two different ways. One way to do this is to just plunge this 3/8 end mill to depth, and that's it. So go ahead and plunge it, and we'll just use holes. We call it a depth of 0.5. So do bolt circle. And just like before, we'll do 8. We'll do our center at 4 and 1.5, and our radius at 1.72 divided by 2, and leave our start angle at 0. So now the last thing we're going to do is pick our hole to skip. So this is our first hole, and it goes counterclockwise from the 3 o'clock position. I'm not sure which way the holes actually move. It says counterclockwise, but I think it's the other way. I think it's clockwise. So it's 1, 2, 3, 4, 5, 6. We'll try number 6. And then if that's not right, we can always just change it. Go ahead and draw it. Okay, so it is counterclockwise, so I was wrong. So that's number 4. Draw it again. Alright, that's it. So that's our counter bores right there. Now we'll go ahead and do it the other way. As far as stuff like this goes, I'd never just plunge an end mill to create a counter bore hole, unless I absolutely had to. You get a really bad finish usually, and your hole is basically whatever your end mill size is. So if your end mill's really undersized or tapered or chipped, it wouldn't be exactly the size you want it to be. If you take a smaller end mill and actually bore this out, you'll have a much better finish, and the hole should be exactly the size you want. It's just a counter bore, so it's not too critical. But we were having a glitch where we couldn't put the tool in the software, and it wouldn't let us do this hole type, so we ended up milling it. So I'll show you how to do that also. Alright, so we'll go ahead and start with milling circle, and we'll just pick this top circle up here just to be easy. So our X center is going to be 4, and our Y center is going to be the 1.72 divided by 2, and 1.5 added to that. Now radius is the 0.375 divided by 2. We can just leave that start angle blank. This time we're going to use tool 61, and we're going to do pocket boundary. Peck depth, we'll do about 0.1. Throw a finish pass in there, and that should be it. So we have one hole all taken care of, so should do it right up here. Okay, so we have an error here. Our tool is too large. So if we go to our parameters, it's this blend offset that's causing a problem here. So we'll use that change parameters we talked about before. So before this number 8 block, we're going to insert, and we'll go to this miscellaneous. And there's a change parameters in here. So basically it's the exact same as the program parameters, except now we can tweak it for just certain parts of the program. So we'll change this blend offset down to 0.1. and we'll see if that works. Alright, so it looks good now. We can zoom in, and we can see it milling it out there. It's going to take a little bit longer, but you'll have a much better finish. Now we just got to rotate this out. So before our mill circle here, we're going to insert, pattern, loop, and loop rotate. Then we're going to do 7 of these. And we pick our center here at 4 and 1.5. Now our start angle is still going to be at 0 because we're not changing from where it originally was. Now our rotate angle is the degrees between each hole. So we had 8 holes. Basically we just take each of these wedges, how much that is, and we know they're divvied up equally between 8 of them, even though there's only 7 counterbores. That we just skip that one like we did in the bolt circle before. So we'll just take 360 divided by 8, and that's going to be our rotate angle. So we get 45, and it's going to rotate in the positive direction. So we're actually going to make this negative 45 since we start at the top. So we do negative 45. Then remember, once you start a pattern, you have to end it. So here's our pattern here. We need to end it here at the bottom. So we'll insert, pattern, end. And if we go ahead and draw it, we should be good to go. Alright, that's it. So our entire part's completely done. One thing we haven't done is the chamfer mill. I'm going to separate that into a different video. That way people can look at that, for example, how to chamfer. So we'll go ahead and save this out, and we're done.